Here in this video, we are going to be finding the optimum local alignment using the two sequences and the position parameters given. And here we have a generalized formula for finding local alignment matrix. However, for the sake of this video, we are going to be finding using an easier method to fill in our alignment matrix. The first stage is the initialization stage. And one thing to take note in any alignment matrix is that the first sequence is usually arranged vertically while the second sequence is arranged horizontally. And also for any local alignment matrix, the first row and the first column are usually filled with zeros, unlike the global alignment matrix. Here we have our first score schema starting from the 0, 0, indicating our initialization stage. So after the initialization stage, to compute any alignment matrix, there are three crucial steps or stages, and the very first one is to take note of the two residues at the particular position or the cell, or what you call the schema. So for this particular position or the schema, which we will label as S to the 1, 1, we can see that the two residues at this position is a mismatch, that is T to the A, and that is our first step established. It is a mismatch. Then the second crucial step to take note is that you are going to be using your gap penalty and your mismatch score or your match score. And for this particular cell, we have established that we're going to be using our mismatch score. And then the third and final crucial stage is to note that after you have computed the gap penalty and your mismatch or your match score, you're going to be picking the highest score amongst the three scores, and that is what you're going to be imputing in your cell. And so to get on with it, the first establishment is that we have a mismatch here because it is T to the A. And then the second step is to calculate the gap penalty and the mismatch score. And for us to do that, we're going to be going vertically, horizontally, and diagonally. The diagonal represents either the match or the mismatch score. And to go vertically, we are going to be using our gap penalty. Also, to go horizontally, we're going to be using our gap penalty. And our gap penalty that was given is -2. So 0, -2 will be -2. Horizontally, 0, -2 will be -2. Then the diagonally, our mismatch score that was given is -1. So 0, -1 is -1. And that brings us to a final stage that we have to pick the highest score amongst the three, which is -1. -1 is greater than -2, also greater than -2. So we input our highest score, which is -1. For the next score schema, which is S to the 1 to the 2. That is for this particular cell. The first step is to check whether the two residues at this position is a match or a mismatch. And here it is a match. That's T to the T, meaning we're going to be using our match score that was given to us, which is +3. And so the next step is to compute our gap penalty and our match score. And the gap penalty that was given to us is -2. So going vertically, horizontally, and diagonally. And this time around, the diagonal will be using the match score. So to go vertically, we have 0, -2, that's -2. Horizontally, we have -1, -2, that is -3. Then diagonally, we have our match score, which is +3. That's 0 plus 3 is 3. Then the last stage is to compare. 3 is greater than -2. 3 is greater than -3. Therefore, we impute our score, which is 3. Coming to this particular cell, which our score schema representing S to the 2 to the 1. That's S21. For this particular cell, the first step is to check the two residues, which is a match. That is A to the A, meaning we'll be using our match score, which is +3. The second stage is to calculate the gap penalty and the match score. So to do that, we're going vertically, horizontally, and diagonally. Vertically, it is -1 with our gap penalty, that's -2, which will give us -3. Coming horizontally, we have 0, -2, which will give us -2. Then diagonally, we have a match, which is 0 plus 3 will give us plus 3. Plus 3 is greater than -3. Plus 3 is greater than -2, which will bring us to input our highest score, which is 3. Same goes for the next cell, which is S to the 3 to the 1. The two residues at this particular position is a mismatch, which will be using -1 for our mismatch score. So going vertically, we're using a gap penalty, which is 3 minus 2, that's 1. 0 minus 2, that's -2. Then diagonally, 0 minus 1, that is -1. And so the highest score in this particular cell is 1. 3 minus 2, which will give us 1. So that is, we're going to be imputing our 1. And that is just how we will do for all the cells till we fill up the alignment matrix. And so I will just go ahead and fill up the alignment matrix. Feel free to compute your own table and compare your scores with the table in the video. So in order not to waste time, I will just go ahead and fill up the alignment matrix. Here we have our complete alignment matrix. And for us to be able to find our optimum local alignment, we first start by identifying the optimum score in the matrix. Here we have 22 as the optimum score. And after that, we trace back from the optimum score through the preceding cells or preceding scores down to the terminating score, or what you call 0. So anywhere you encounter 0 in the matrix, starting from the optimum score, you terminate the algorithm. So here is how we go about it. So starting from the optimum score, or what we call the highest score in the matrix, we go by checking the corresponding residue at the particular position. And then here we have the T corresponding to the T, telling us that there is a matching sequence right here. And so for us to get the preceding cell or the preceding score, usually we identify a matching sequence from the diagonal score or the diagonal cell. So to confirm that, using our diagonal score here, which is 19, since it is a matching sequence at this particular position, T corresponds to T, we use our matching score, which is 3, and that is 19 plus 3 gave us 22, and that's for confirmation. So we go ahead to give it a shade. Usually I advise that for every preceding score or cell, you shade or you represent with an arrow so that you can be able to easily identify or write out the alignment sequence that is right here. So our preceding score here is 19. We go ahead to check the corresponding residue at the position, which is A corresponding to A, and that is also a match. We can easily identify that our preceding score is the diagonal score, which is 16. Going ahead, we also go to check the corresponding residue, that's C to C. It's also a matching sequence. So our preceding cell is 13. And so here, corresponding residue is G to the A. So we have to confirm whether it's a mismatch or our score was gotten from a gap penalty. And so to do that, we go by analyzing vertical, horizontal, and diagonal. And from here, vertically, we can see that the the preceding cell, which is 15, using the gap penalty, that's 15 negative 2, gave us 13. If we were to go using the diagonal score, which is 10, it would have been a mismatch score, which is -1. That's 10 -1 would have given us 9. So we can confirm here that our preceding cell was gotten from our preceding cell here is a gap penalty, and our mismatch score here was gotten from a gap penalty. So we have a shade at 15. Then the next one, we go checking the corresponding residue, which is C corresponding to A, and that we have to confirm whether it is a mismatch or a gap. And from here, we can confirm that by checking 17 negative 2, which is the gap penalty, gave us 15. If we were to go diagonally, that would be 12 negative 1, which would be 11. So we can confirm that our preceding cell is 17. So we have a shade at 17. Then the next, we go for the corresponding residue, that's A corresponding to A, and that is a match. So we give it, we know that our preceding cell, our preceding score is the diagonal score, which is 14. So we have a shade at 14. T to the T, that's a match. We have a shade at our diagonal score, which is 11. G to the G, that's also a match. We have shade at the preceding score, which is 8. C to the C, that's also a match. We have our shade at the preceding score, which is 5. A to the G, we have to confirm whether that's a mismatch or a gap. So here we have 4 in the negative side. 4 negative 2 would give us 2, and that is incorrect. So checking diagonally, we have 6 negative 1 gave us 5. So we can confirm that our preceding score is 6 right here. And then we have T corresponding to T, that's a match. So we have our preceding score to be 3, which is a diagonal score. Then we have A corresponding to A, and that is also a match, where we have our preceding cell or preceding score to be 0, to be pointing to 0. And 0, like we said earlier, is the terminating score. And so right here, our algorithm terminates. So after identifying this preceding cells or scores, or and we've shaded or um, represented with arrow, we then go ahead to write out the aligning or the alignment sequence. And how do we do that? You can start from either the bottom or the top. Starting from the top, we have our first shaded score here, which is 3. We do not start from the terminating score because there is nothing T is corresponding to here. So we have 3 as our first preceding score, which is A corresponding to A, and that's a match. So we write it out, A corresponding to A. And then the next one, which is 6, we have T to T, which is corresponding. That's T to T, that's a match. Then the next one we have is 5, A corresponding to G. Here is a mismatch from the preceding score. We identify that it is a mismatch. And to represent a mismatch in an alignment sequence, usually use a period or what you call the full stop. So that's A corresponding to G, which is a mismatch. Then the next one, which is 8, C corresponds to C, and that is a match. Then 11, which is the next score, G corresponds to G, that is also a match for 14. T corresponds to T, that is also a match. Then the next one, which is 17, A corresponds to A, that is also a match in the alignment sequence. Then the next one, which is 15, C corresponds to A. Well, because it is a gap, here we represent it as C corresponding to nothing, which is the gap. The gap score is represented by the hyphen in the alignment sequence. And so usually the logic is if the gap is represented at the bottom sequence, as the second sequence, is telling us, don't forget from onset, we said the first sequence is usually on the vertical side, while the second sequence is usually on the horizontal side for any alignment matrix. So for us to be able to represent the gap at the second sequence, we've identified here that our gap corresponds to the column here that's telling us that A is missing. If our gap were to be at this point as the horizontal part, which is 10, then we would say that our C is the one that is missing. So here our gap here is at the horizontal, which is 17. So the second sequence here is the one that is missing, that is A, and that's why we have C to the gap. The next number, which is 15, that's C to A, is also a gap. Oh no, I mean 13. That's G to A is also a gap. So that's G to A. We have a gap there. Then the next one, which is 16, we have C to C, which is a match. And then next one we have 19, A to A, which is also a match. Then the next one, which is optimum score, that's T corresponding to T, and that is a match. Here we can perform our alignment score or confirm our optimum score in the alignment matrix by using the position parameters for match, mismatch, or the gap penalty, each one corresponding to the aligned sequence. So the positive 3 corresponding to the match, the negative 1 to the mismatch, the negative 2 to the gap. And that is just how we find our optimum local alignment.